All right, so this is the 6.2 notes. We're going to be looking at our first quadrilateral, the parallelogram. Okay, so right up here at the top, a parallelogram is a quadrilateral, so four sides, with both pairs of opposite sides parallel, hence the name. Okay, so this is the symbol that we use to name a parallelogram, kind of like a slanted rectangle. So right here, this is parallelogram ABCD. It says by definition that your both pairs of opposite sides are parallel. So meaning side AD would be parallel to side BC. You see how they both have just one arrow notating that those two sides are parallel. Side AB is parallel to side CD, and those are notated with two arrows, meaning that those two sides are parallel. Okay, so that's the definition, but there are more properties of parallelograms, okay? So I handed out a chart, a little kind of study chart for properties of all the quadrilaterals. So as we go through these notes, make sure you're filling in that chart. That way you can use it kind of like a study guide, okay? Because there's lots of properties for each quadrilateral that we study, and we will be looking at a total of about 6 quadrilaterals, so you're going to need to know properties for each. So here are properties of parallelograms. Okay, these are kind of like abbreviations, so when you read it, we've shortened some words, we are using symbols, but this, you know, over here is just kind of explaining the abbreviation and an example. But here are your properties. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are the opposite sides parallel, but opposite sides are also congruent. So this one tick mark and one tick mark, those two sides are congruent. 2 tick marks, 2 tick marks, those two sides are congruent. If it's a parallelogram, then its opposite angles are congruent. Okay, opposite angles. All right, we notice how sides are directly across from each other, right? Angles, you're going to be looking diagonally. Opposite angles, J is opposite to L. Those have one loop, those are congruent. K is opposite to M. Those each have 2 loops, so those are congruent. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive angles are supplementary. Okay, so remember consecutive angles mean that they are next to each other, meaning x plus y, right? X plus y this way, add to 180. X plus y this way, add to 180. Same for over here, y plus x, x plus y. So consecutive meaning next to each other, right? Side by side, either this way or this way. They are supplementary or they add to 180. If a parallelogram has one right angle, then it has 4 right angles. Okay, remember, if it's a parallelogram, opposite angles are congruent, so 90 and 90. Consecutive angles are supplementary. 90 plus 90 equals 180. Okay, so that kind of proves that theorem. If there's one right angle, then there is 4. All right, so those are the properties that you need to remember. Remember, this is also a property. It's the definition of a parallelogram. Both pairs of opposite sides are parallel. There is one more property that isn't listed here that you can prove, and I'll write it down here. Okay, so one pair of opposite sides are both, okay, both parallel and congruent. So if one pair of opposite sides are both parallel and congruent, then it's a parallelogram. Okay, so that is one property that isn't listed here, but it does, if you can prove that one pair of opposite sides are both parallel and congruent, then it is a parallelogram. Okay, Now the next page, let's kind of do some questions and examples using these properties. All right, it says find the value of x and y in the parallelogram below. Okay, so if I start with x, all right, these two angles are consecutive. They are not opposite. We know that consecutive angles are supplementary, so meaning they add to 180. So I would take 4x plus 2x minus 6 and set it equal to 180. That gets me 6x minus 6 is equal to 180. Add over 6, 6x is equal to 186. Divide by 6, x is equal to 31. Okay, if you notice that y is on a side, okay, this side is y plus 8, this side is 5y. These are opposite sides, and if it says in the parallelogram, it is stating that this is a parallelogram, and parallelograms, opposite sides are congruent. So if they are congruent, I would set them equal to each other. 5y is equal to y plus 8, subtract over y. 4y is equal to 8, divide by 4, y is equal to 2. Right here in parallelogram, remember that's a symbol, ABCD. Suppose that the measure of angle A is 55, meaning that the angle C is 55. Okay, if these are supplementary, right, consecutive angles, that means that this angle B and D has to be 125. Okay, I'm just filling in information that I should know. AB is 2.5 feet, meaning that CD is 2.5 feet. And BC is 1, meaning AD is also 1. So here it's asking for side DC. Remember that's the measure of side DC, 2.5 feet. The measure of angle B is 125 degrees, and the measure of angle C is 55 degrees. Just remember your symbols, guys. That little M with this like greater or less than symbol, that's the measure of angle. And if I have two uppercase letters, that is a side. Okay, find the value of x in the parallelogram. So x is on angle L, all right? I know that opposite angles are congruent. So there's two ways of solving this, right? Opposite angles are congruent. We can set 2x minus 1 equal to 75. Or consecutive angles are supplementary. I could take 2x minus 1 and add it to 105 and set it equal to 180. You'll get the same answer for x, but this right here is the shorter method. Opposite angles are congruent. Set them equal to each other and solve. So if I add over 1, 2x is equal to 76, divide by 2, x is equal to 38. Okay, right here, what is the measure of angle STU? So if I follow that order, STU is this entire angle, all of angle T, okay? I want to know what is this angle right here. It is opposite. Angle T is opposite to all of angle R. If you look, angle R is cut into two pieces, 30 and 25. Okay, meaning all of it is equal to 55 degrees. So the measure of angle STU is equal to 55 degrees. Okay, and then they want to know the measure of angle RST, which is all of angle S. The measure of angle RST, remember these would be consecutive, right? Consecutive angles are supplementary. If this is 55, 180 minus 55 would be 125. So again, if you don't just have like J, angle M, angle L, angle K, you have to follow the order of the letters. STU. If it was angle STB, it would only mean this angle right here. Or angle UTB would only mean this angle right here. So just make sure you're understanding what you're solving for. Okay, the last property of parallelograms refers to the diagonals. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Remember, bisect means to cut in half. Diagonals run from one angle to its opposite angle. So here is diagonal AC. If it bisects, right, wherever they intersect is going to cut the diagonals in half. So I have one tick mark and one tick mark. Here's another diagonal, BD. The angles bisect each other, so this point is cutting each diagonal in half. So this part BP is congruent to this part PD. So what I can conclude, right, about diagonals bisecting each other in parallelograms is that they're going to intersect at the midpoint of each diagonal. Okay, so that's what I want you guys to think about for this property. If the point of intersection, right, where the diagonals bisect is at this point right here. Okay, if it's cutting them in half, then that means that this point has to be a midpoint for this diagonal and also a midpoint for this diagonal. It does not mean that the diagonals are congruent. It just means that they both are intersecting at the same midpoint. Okay, so if I'm solving for z in the parallelogram below, it's pointing that this piece of this diagonal is 3z minus 4, and this piece is z plus 5. Diagonals bisect, meaning that this is a midpoint, making this congruent to this. If they are congruent, set them equal to each other. 3z minus 4 is equal to z plus 5. Get your variables on one side. 2z minus 4 is equal to 5. Add over 4. 2z is equal to 9. Divide by 2. You can leave it as a fraction, 9 over 2, or you can have 4.5. Okay, so this last one, I'll try to hurry up within the next 3 minutes. It says determine the coordinates of the intersection of the diagonals. We just stated that they intersect at the midpoint of each diagonal. So here's parallelogram ABCD with vertices at A, negative 4, 6. Okay, B is at 5, 6. C is at 4, negative 2. And D is at negative 5, negative 2. Okay, so I don't really need this graph besides knowing what my two diagonals are, okay? Because I know that if they have diagonals AC, right, from one opposite angle to the next, and DB, okay, yes, I can kind of guesstimate where they intersect at, right? But I want to make sure I'm accurate. But what I do know is since these bisect each other, they are intersecting at the midpoint of each diagonal. So I want to find the midpoint of AC, and I want to find the midpoint of BD. It should be the same point. Remember the midpoint, if I take the two x values and I add them together and divide by 2, and the two y values and add them together and divide by 2. Okay, that's my midpoint formula for my formula chart. So A and C. A is negative 4 for the x value, and C, positive 4. Well, negative 4 plus 4 is 0. 0 divided by 2 is 0. The y value, 6 plus negative 2, or 6 minus 2. That's 4 divided by 2. That's 2. Okay, and if I look, here's my origin. Here's 0, 2. If I check BD, okay, my x values of B is 5. My x value of D is negative 5 divided by 2. Again, 5 and negative 5 is 0 divided by 2. That's 0. The y value is 6 and the y value of negative 2. So 6 minus 2 divided by 2, which is 4 divided by 2, or 2. So the coordinates of the intersection of the diagonals, okay, of parallelograms are going to be at the midpoint of each diagonal. Okay, so make sure you know that.